earth-in equipment, ground-in equipment, ground-in antennas, earth-in antennas, ground-in this, ground-in that. What actually do we need to ground? Do we need to ground all our equipment? And actually, what is ground or what is earth? Does it actually exist? Well, let me give you my opinion on grounding and earthing.
We have this big water pipe, for example, that's down in the dirt. Is dirt a really great conductor? Not really. It's a very unpredictable conductor.
Yes, it can certainly be confusing, can't it? Earth in our station. What do we earth? What do we ground? How do we connect this? How do we connect that? Well, I should first of all say that we are talking about RF earth. We're not talking about the AC mains earth. That's something totally different. You shouldn't tamper with it. That's a job for a qualified electrician. We're talking about RF earth, earth in our station. What do we do? How do we do it? What's right? What's wrong? And what is a waste of time? At the beginning of this video, I played a short audio clip from an ARRL lecture that K6WX gave, and it's quite interesting actually, because you know, earth or ground, the two terms are interchangeable. It's very difficult to define. It's not an absolute thing. It's really, I suppose, a reference point. For example, I could put a copper stake into the ground there and a copper stake into the ground there, but there would be resistance, quite high resistance, because ground is a pretty poor conductor. So those two ostensibly grounded poles would actually have a potential voltage between them because they are at different points in the ground. If we applied a generator to one of them, we would not measure the same point of voltage there as we would from there. So ground, what is ground? What's the point of grounding anything? What's the point of earthing anything? But you see, I've got a radio upstairs, a transceiver upstairs, and now have a look at the schematic diagram. It clearly shows that we've got a ground plane. The base, the chassis of the radio is clearly shown with a ground symbol. And we've got a voltage here and a voltage there. And then we've got all sorts of components going down to this basic ground system. We'll call it a ground plane. And it's clearly got an earth symbol on it. But that radio is totally different from the earth that I just suggested with the two copper pipes in the ground. So what are we talking about? It's getting mystifying, isn't it? One of the questions that regularly I get asked is about grounding the equipment, earthing the equipment. And I think because we're told how important RF ground is for aerials and so forth, and because many years ago the equipment had the aerial going straight into the transmitter, and it was advised to ground the transmitter because effectively the ground was part of the aerial system. And this really is important when we're talking about RF. We're not talking about AC mains, we're talking about RF. When we're talking about RF, you can't actually ground your station. It's actually impossible, and I'll explain why it's impossible. Let's say I'm operating upstairs. I'm not sure how high it is. It's probably about 8 or 9 foot. But anyway, let's suppose for the purpose of this explanation, I'm 8 foot above the ground. I'm upstairs. And I've got my equipment here. And there's terminals on the back which says ground. So you think, okay, well, I've got to ground this. And so we connect a wire to the transceiver and we take it through the wall down to a copper spike or a copper rod that we've hammered into the ground. And we connect it up to the gear. So we've actually grounded our transceiver, haven't we? Well, no, we haven't. And I'll tell you for why. The reason I've chosen 8 foot is because 8 foot happens to be a quarter wave on 10 metres, but the principle applies across the spectrum. If we have 8 foot of wire into the ground and coming up to the equipment, that's a quarter wave. It's a quarter wave length. So it could end up with a bit of voltage on the equipment there, because if we accept that Earth is going to be 0 volts, and that's debatable, we could find our equipment is actually at the top end of a quarter wave, and the top end of a quarter wave has got RF volts on it. So there is no way that connecting your equipment with a bit of wire down to a copper spike or a copper rod is going to be ground in terms of RF. In terms of AC voltage, totally different. But in terms of grounding your equipment, it doesn't ground it. And in fact, listening to more of K6WX lecture, she says basically, don't ground your equipment. It doesn't form any function, there is no advantage, and it could in actual fact induce a bit of noise. Your equipment from a safety point of view is grounded by the electricity suppliers. That equipment is safe in terms of health and safety. So why do we have the terminals on the back of the equipment? Well, I'll come back to that in a minute, but suffice to say that it is a pointless exercise grounding your transceiver or your transmitter or all your gear to a copper pipe. Even if you're at ground level, you've still got the basic problem that the length of wire going through the wall to the earth is a significant length, and you can't have a ground. You can't actually have earth in two places, really. If you regard earth as the soil outside, that's fine, but the equipment up here will be at a different potential. So there's no point in grounding your equipment. I hope I've made that clear.
So with all of this, what happened to ground rods? Well, my opinion is, if you're not worried about lightning, you're mostly wasting your time with them.
So what do you do if you've got a station upstairs, as many of us have, and you're worried about RF on the equipment and so forth? Well, there are two things you can do. The standard precaution really is, if you're worried about that or you think you've got a problem, is to use ferrite rings or clip-on ferrite clamps, and they will remove most of the RF and probably all the RF that's likely to cause any trouble from the chassis of the equipment. That is the sort of standard way of cleaning things up and making sure you don't get too much RF on the equipment. The alternative, if you do have a serious problem, there is one very nifty way of treating it. Perhaps you've got a problem on a particular band. Let's say, for example, you've got a problem on 20 meters. You're operating on 20 meters. You've got a linear amplifier going, and you got a bit of an RF problem. Well, if you've got an RF problem, it's highly likely that there's RF on the chassis of the transceiver, the linear, or both of them. And what you can do then is to use a quarter length of wire, put a quarter length of wire onto the chassis of the transceiver. Now the chassis of the transceiver will be connected to the chassis of the linear amplifier by your coax cable. If you cut yourself 16.5 foot of wire, which is a quarter wave on 20 meters, what happens? Well, when you attach it to the chassis of the transceiver, the voltage point moves to the end of the wire, because it's a quarter wave long, and the end of a quarter wave is a high voltage. So it has the effect of moving the voltage, high voltage, from the chassis of your transceiver to the end of this quarter wave wire. Now, if you've got a problem on 2 or 3 bands, it is quite okay to get quarter wave lengths of wire for each band, because the actual length is not super critical. get a quarter wave length of wire for each band that you've got a problem with, just wrap it together with tie wraps and just run it along the floor. That on each band moves the voltage from the chassis to the end of that quarter wave length of wire, and it'll clean up the problem. Now, one word of caution, and that is the end of that quarter wave length of wire is going to be high voltage, or potentially high voltage, and you can get an RF burn, and an RF burn is not very nice. It's like a needle going into you and you smell burning flesh. So best thing to do is to tape over the end of that wire so it can't be touched, and that together with, or instead of, the RF clamps and RF chokes will clean up your equipment. Now, another problem or question is, should all my equipment be connected up together with some sort of earth strap? Because on the back of my equipment, the back of my transceiver, the back of my power supply, the back of my amplifier, etc, 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 has an earth terminal. Well, the answer is probably not, because all that equipment is connected, or the earth side is connected up by the negative side of the power lead, the sheathing of the coax, etc. But if you've got a lot of equipment, then it's not against sort of rules to connect it all up with some form of bonding. You need basically some heavy gauge wire or a bit of sheathing or something like that, and connect it all up. It levers it all out, so it's basically almost all the same potential. Bear in mind that a length of wire that long is going to have no consequence at all on 160 metres, but on 10 metres or 4 metres or 6 metres, that could start to become a significant length. But if you bond all the equipment together, there's nothing wrong with that at all. It may help. It may help with a bit of noise. It may not. It's not absolutely essential. I operate up to 700 watts now in an upstairs room. I've got no earth connection to the chassis at all. I have no problems, and I haven't bothered to actually strap all the earth terminals together, because every bit of equipment that is in that chain is already connected courtesy of either the power supply or the sheathing of the coax cable. And of course, the sheathing of the coax cable is quite a good conductor of RF anyway, and generally speaking your amplifier is going to be near your transceiver, so there's not really a problem there. That's the way I operate. So what about earthing antennas? Well, there's nothing to be gained by earthing the coax feeder from your or to your antenna. Certainly if it's a dipole or unbalanced feeder line, then there is nothing to be gained by earthing it. If you're using an end-fed wire, then there's two things you need to consider. First of all, what sort of form is it taking? If it's an end-fed half wave, then basically all you need to do is to have a choke at the point just before the coax goes into the first thing in line, which may be a matching unit, may be a VSWR meter, may be a transceiver. Use a coax choke. And the same really with random wire. Use a coax choke at the point before the feeder goes into the first bit of equipment in line, and that usually is either an ATU matching unit, a VSWR meter, or maybe you take it straight in the transceiver. But put a choke on it. That keeps the RF from getting into the chassis, because you will have what we call common mode currents with those sort of areas. Common mode currents coming down the outside of the sheathing of the coax, and that can cause a little bit of a problem. Put a ferrite core, ferrite choke on it, and it should clean it up completely. Now, although we talk about earth, if we talk about the dirt on the ground, the mud, the clay, whatever it is you got in the ground, though we talk about earth as a nice conducting layer, it actually isn't a very good conductor of RF. It reflects RF, but as regards the conductivity, it's actually very poor, generally speaking, unless you've got salt water, and not many of us have got salt water. So we put down radials, if we're using I'm talking about areas that need sort of radial systems now, rather than horizontal aerials that don't need radials, they just rely on the natural reflectivity of the soil below them. But if we've got a vertical antenna, then we do need some radials, because the other half of the antenna is the ground beneath it. A quarter wave vertical, regarded as a dipole, the 1/4 wave or the quarter wave that sticks up in the air is half of the dipole. The other half of the dipole is actually the ground beneath it, and we know it's a very poor conductor, generally speaking. So we put radials down, and that helps tremendously. And as a rough guide, around about 16 radials is a pretty good number of radials to put down. And I think we've found out recently that they don't have to be quarter wave radials, they just have to be radials of some sort of length. And I've recently been messing about with radials, and my radials have been about 3 meters long. If you have about 16 of those radials down, then you'll get fairly good performance when you're vertical. But if you were to raise the radials above ground and make them tuned radials, then you only need 2 radials. 2 radials will give you as good, if not better, performance than a whole load of radials laying on the ground. But the caveat is that those 2 radials must be resonant on the frequency of operation. So it does mean to say that if you've got a vertical that is multi-band, you're going to have a pair of radials for each band, a pair of resonant radials for each band.
So ground planes have these things we call radials sticking out of them. The signals sort of reflect, if you will. And if you put them on the dirt, you will find that you get more loss from them. And that's why you generally want more. And they don't actually have to be on the ground, right? They can be up in the air. And if they're up in the air, you can tune them to the frequency of interest, and then you can get away with as few as 2. That's what the Motorola guys found out.
One other thing to talk about earth is if you do hammer a copper pipe into the ground as an earth for any reason, it may be for a vertical, because you can actually put a copper pipe in the ground and the vertical will work. It will give you a reasonable VSWR because the earth losses will be quite high, and so therefore the VSWR meter will see a good match. In actual fact, you'll be losing quite a lot of power on the earth losses, and I would always suggest you put down radials for verticals. There's no need to hammer that copper pipe deep into the ground, because remember, RF travels on the surface of things. It doesn't travel inside, it travels on the surface of things. So there's nothing gained by whacking a copper pipe into the ground 3 foot into the ground. You don't achieve anything at all. You might as well just hammer it a few inches into the ground. It's just as effective. So there we are. So you see, Earth is a funny thing, really, isn't it? It's not a particular point. It's not a particular point in a 3-dimensional picture. It can be there, it can be there, it can be down there, it can be up there. And that Earth is not connected to that Earth, even though we call them Earth. That Earth is not connected to that Earth, and that Earth is not connected to that Earth, etc., etc.
And this is actually a lot like voltage. Is there a ground for voltage? Well, not really.
In summary, nothing to be gained by earthing all your equipment in terms of performance. If you do want to earth it, fine, go ahead. You may increase the noise, you may not. One other thing before we finish, and that is lightning protection. Basically, there isn't such a thing as a lightning arrestor, an inline lightning arrestor. If you've got an inline, what they call lightning arrestor, if lightning strikes that antenna or that feeder, it's going to blow it sky high. It's going to just obliterate it. It's going to vaporize it. Basically, the things that you put in line really should be called static protectors, and they will actually discharge static to a degree, but probably only to a degree in terms of safety. They won't really discharge, I don't think, enough to reduce noise. But a static protector is not a bad idea if you're worried about static. But if you're worried about storms, then the only way to protect your equipment is to disconnect the equipment or disconnect the feeder cables to the transceiver. And this is where the guy that's earthed his equipment potentially could suffer more damage, because lightning always wants an easy route down to earth. And an easy route down to earth is your transceiver connected to a bit of wire down going into the soil at ground level. Bear in mind, we're now not talking about RF, we're talking about lightning now, very, very high voltages.
So what I've seen is that some people will have the coax from their antenna come into the shack and get screwed into the back of the radio, and then that little ground wing nut on the back of the radio gets connected to the ground rod. You're inviting the lightning into your home. Not good. It's not a friendly neighbor.
So, if you want to protect your equipment, then unplug the aerials and throw them out the window and let them dangle somewhere. That is enough, at least to protect your equipment. It may not stop the feeder and the aerial being struck, but at least it won't damage your equipment. So there we are. Anyway, as usual, thank you for watching this video, much appreciated, and thank you for all your comments, they're equally appreciated. Don't forget to press the subscribe button if you want to know when the next video comes up, because I don't actually publish videos on any particular day, I just do them as and when. And as and when usually means at least once a week, maybe a bit more than once a week. There we are. Anyway, you take care, enjoy ham radio, and I'm now going to answer this phone that's ringing.